So this will be my final project based on vectors and geometry. So here I created a question. A spacecraft is controlled by two thrusters that apply forces in different directions. We have the main thrusters and the side thrusters, and then I put the amount of force that they are producing. And here I have three questions. For A, we will be finding the angle between the two forces, and then we'll find the cross product, or we'll find the rotation by using the cross product. And after that, we could look at everything and see what it all means. So starting off with A, we'd be using the dot product. And first, before we find the magnitude, we would like to find how parallel all the thrusters are compared to each other. So we have, let me change this to white. We'd have F1 and F2, which is just the thrusters. And here, so on the first spot of each other, we have 5 and 2. So we multiply those by each other. Plus 0 times 3. And 0 times 1. So here, they'll all equal 0 except 5 times 2, which we just are left with 10. And now we go ahead and find the magnitude of force 1. So we could go ahead and do that, which is just the square root of 5 squared plus 0 squared plus 0 squared. So this would just give us 5 times 5 is 25, and the square root of 25 is just 5. And for force 2, it'd be the same thing, except different values. So we have 2 times 2, or 2 to the power of 2, 3 to the power of 2, and 1 to the power of 2. So here we have 4 plus 9 plus 1, which is equal to 14, and the square root of 14 is approximately 3.74. And here we could end up using all of this and find the angle. So we have theta equals cosine to the power of -1, and then 10 divided by 5 and 3.74. And this would all equal to 57.7 degrees. And this shows us how it rotated and shows us just the angle that it's headed towards. So using this, we could end up going to part B and finding the rotation and see what is causing it to go to this angle. So we can start off with the cross product. So we know we are given all the necessary stuff here, and it'd be there we go, I, J, K, 5, 0, 0, 2, 3, 1. So I would be 0 times 1 minus 0 times 3, then minus J, 5 times 1 minus 0 times 2, and then for K, we'd add plus, and we'll just move K down here. K, 5 times 3 minus 0 times 2. So here our I would be equal to 0. Our J would be 5 and plus K, which is 15. And we would just create that at the bottom. So 0, it'd be -5 since we have a negative sign right there, and 15. So this does show there was some type of rotation or torque happening, because if, say, we have 0, 0, and 0, this means that there's no rotation at all happening on the spacecraft. But since we've ended up with these values right here, it shows why we are getting this type of degree that's going on. And now we want to see how the magnitude of the cross product relates to the rotational strength. So we get the magnitude of both F1 and F2 should equal 0 squared plus 25 plus 225, and here would be 250, and that would give us around 15.8 newtons. So this magnitude just shows us how strongly the two thrusters cause the spacecraft to rotate. And then the larger it is, of course, the more torque there is, or rotation. And looking at all of this, I kind of made a graph, or a chart, let's say. But here it just shows everything that's going on, everything that we've gotten. And it shows like what we started with our forward thrusters, our side thrusters, and then the rotational axis that is causing it to hit this degree right here. And this will conclude my final project.